All right, how can you rewrite the following function to identify its transformations? So at this point, square root of 9x is, this isn't working. Square root of 9x is not in the form that we just looked at. So how do you get it in that form? Well, if you recognize that you can take the square root of 9 and it becomes 3, now it's in that form, right, where that 3 now represents the stretch. So your a value is 3, and the way that the graph is going to look, if the f is the parent function, then the orange is stretched by a factor of 3. Okay. For part B here, first thing I would do is take 4x plus 16, factor a GCF of 4. That 4 is a perfect square, so you can take a square root of 4 and it comes out as 2. So your a value is 2. Your 4 there is going to move it left 4, and then 7 is going to move it up 7, and you're going to end up with a graph that looks like that. So it's just a matter of factoring and simplifying the radical. All right, you've got 2 examples to try here, so pause it, try them, and come back and check your answers. Looking at part A, I factored a 7 away from 7x minus 3.5 and got 7 times x minus 0.5. Since 7's underneath, it still will affect the stretching of the graph. It's just going to be by square root of 7 instead of 7. Right would be 0.5 and down would be negative 10. For part B, we split the 12 up into 4 and 3. Square root of 12 is 4. And then 3 is what's going to be left behind. So square root of 4 comes out as 2, multiplies the negative 2 is already out there, and you get negative 4. So since that a value is negative, it's going to reflect. So it's going to go down instead of up. It's going to stretch by 4 root 3. So both coefficients inside and outside would represent the stretching factor. And the plus 4 on the outside means it's going to go up 4. All right, let's take a look at the next example.